My thanks to Tony Heller for checking my channel for accuracy in his video Debunking the Debunker. A lot of people asked me to respond, so I'm happy to do so. I'll go through his claims in chronological order. Here's the first one.
He claims that a tiny bit of cooling triggers ice ages and a tiny bit of warming ends them.
Well, the researchers I cite conclude this, not me.
But he doesn't provide any evidence of the magnitude of these changes.
Actually, I do. I not only give the figures, I cite and show the study they came from. This is from my video, Does CO2 Lead or Lag Global Warming? A paper by Lorius et al. Shows that insolation has varied by only 0.7 watts per square metre over the last 160,000 years. In other words, the tiny amount of forcing due to the Earth's orbit wasn't enough to defrost miles of thick ice covering a large part of the planet.
Listen carefully to what he says here.
But each time something had to act as that initial trigger. Something had to nudge the round weight just a fraction. A strong contender has always been regular cyclical deviation in the Earth's position or orbit, changing the amount of sunlight the Earth received. Whatever it was, in the depths of the Ice Age, this change melted a tiny part of the ice sheet and released carbon gases from the soil and from the warmer oceans.
Whatever it was? He doesn't actually know what the trigger of the ice ages is, but he claims to know that the magnitude of it is small.
But didn't I just explain what researchers think it was? Tony even played the clip. A strong contender has always been regular cyclical deviation in the Earth's position or orbit, changing the amount of sunlight the Earth received. These orbital movements and wobbles are called Milankovitch cycles. In another video, I explain that again. Researchers say carbon dioxide was not the cause of the initial warming during any of the recent deglaciations. The most likely trigger was the Milankovitch cycles, changes in the Earth's tilt and orbit that caused more insolation.
What if the effect of those orbital cycles was actually very large? Then his entire theory goes down the drain immediately.
But as I point out, researchers have calculated that they aren't large. And again, it's not my theory. Professional researchers know very precisely what these orbital variations are, and they can calculate within given margins of error how much they affect the energy budget of the Earth. Of course, Tony can speculate that it's much bigger or much smaller. He's free to imagine any figures he likes. But researchers can't do that. They have to go with what the measurements and calculations show. And as a science reporter, I can't do that either. I have to accurately report their results. Tony goes on to describe how a small amount of warming causes oceans to release CO2, since carbon dioxide is less soluble at higher water temperature. I explain exactly the same thing, so no argument there.
So the relationship here, as Potholer correctly stated, is that CO2 follows temperature. Temperature changes first, then the CO2 changes later. What he blew over in his discussion was that Al Gore said the exact opposite. He tried to make it sound like CO2 drove the temperature.
He did indeed, and I pointed out his mistake very clearly. In his film An Inconvenient Truth, Al Gore used a graph like this to show a correlation between carbon dioxide levels and increased temperatures. But he obscured the fact that the carbon dioxide increases lagged the temperature increases by 800 years. So I didn't blow over this at all. It's right there.
Billions of school children around the world have been lied to about this topic, and Potholer didn't seem to think that was very important.
Now, that's a bit unfair. I think that's extremely important, and if you'd asked me, Tony, I would have been very happy to tell you that. I've made no indication in any of my videos that I'm not concerned about children being misinformed about science, whether it's by Al Gore or Laurie David or anyone else. I've frequently spoken out in my videos about the need to stop junk science creeping into classrooms, and I'm happy to repeat that now. I've also said schools need to spend more time teaching children how to tell the difference between real science and junk science on the internet. But let's just get back to what Tony claims I agree with.
So the relationship here, as Potholer correctly stated, is that CO2 follows temperature. Temperature changes first, then the CO2 changes later.
Well, I didn't say the relationship here is that CO2 follows temperature, obviously, because this is a graph covering several glacial cycles. What I said was that CO2 followed temperatures in the early stages of deglaciation in the southern hemisphere, because I'm reporting the conclusion of scientific studies. In the latter stages of deglaciation shown on the graph, and in the northern hemisphere, CO2 led temperature rise. So just as it's wrong for Al Gore to give the impression that CO2 always leads temperature changes, it's wrong for Tony to give the impression that CO2 always lags. If Tony's concerned that billions of schoolchildren are being lied to about this topic, and I don't doubt his sincerity, then I hope he'll join me in insisting that schoolchildren should be told what the science says, which is that carbon dioxide does both. It leads and lags temperature at different stages in the glacial cycle.
Now let's go back and look at the ice core graph again. The graph shows swings in temperature of about 10 degrees centigrade during glacial cycles. These correspond with swings in carbon dioxide level in the atmosphere of about 100 parts per million. Now remember what Potholer said. He said that a very small change in temperature causes feedback from carbon dioxide, and that we get a 10-degree swing in temperature from a 100 part per million change in CO2.
Does anyone remember me saying that we get a 10-degree swing in temperature from a 100 part per million change in CO2? No, because that would imply a ridiculously high figure for the Earth's sensitivity, which is how much the Earth responds to carbon dioxide forcing. Did Tony show a video clip of me saying that? Of course not, because I never said any such thing. And yet, when Tony made that claim, some people simply believed him without checking. That's why I got a couple of rather abusive messages on my channel.
And that is completely ludicrous.
It is, which is why I didn't say it.
Not even the most outrageous claims of climate sensitivity come anywhere close to that level.
I didn't say that, Tony. Okay, just to settle this, here's what I did say about climate sensitivity. And these estimates show that for a doubling of CO2 concentrations, we should see a rise in global temperatures of between 2 and 4.5 degrees. Now, that's what I reported. So what does Tony Heller say?
According to the United Nations Intergovernmental Panel on Climate Change, climate sensitivity is somewhere between 1.5 degrees centigrade and 4.5 degrees centigrade for a doubling of CO2.
So it turns out Tony agrees with my reporting of the sensitivity estimates. There's a reason for the small ½ degree difference in the lower estimate, but this is essentially the same result. So I didn't say that a 10-degree rise in temperature came from a 100 part per million rise in CO2, and certainly no study I've ever read has made such a claim or given that interpretation to the data used to make the graph. Tony Heller assumed that that's what the graph shows because he made a basic error when he tried to interpret the graph for himself. To find out what he got wrong, we first need to find out where he got this graph from. Tony doesn't tell us because he doesn't give his sources, so I had to track it down myself. It's been passed around the internet a lot, but by searching the image and screening the time it was first uploaded, I finally found the first posting of it from a slideshow, and that led me to this slide presentation at Harvard. The data for the graph, according to the authors, came from this paper by Petit et al. Reading Petit's paper, which gives us more detail about how the data were gathered, it's clear that the temperature scale on Tony's graph is not measuring average global temperature. The authors measured oxygen isotopes in the air bubbles trapped in the ice, which are good proxies for air temperatures. So, as they explain in the study, they're measuring temperature at two places: where the precipitation formed, in other words, where the snowflakes formed, and where the snowflakes fell and were later compressed into ice. To put it in even simpler terms, they weren't measuring global temperatures at all. They were measuring Antarctic temperatures. So Tony's wrong to infer climate sensitivity from this, because climate sensitivity is based on average global temperatures, like the average global temperatures Tony looked at when he cites the IPCC result. I'm sure everyone understands the difference between these average global temperature figures and these Antarctic temperature figures.
Under Potholer's feedback theory,
Not my theory, mate.
we would have expected that as CO2 spiked, temperatures would have gone up too.
Okay, there's obviously a genuine belief that this is my theory, so I'd better explain that the conclusion that post-glacial warming was amplified by positive feedback is a well-accepted scientific principle. Anyone with a passing interest in climate science would surely be aware of the mountain of studies that have been written about it. I've explained these positive feedback factors many times, citing scientific studies. So if anyone thinks it's my theory, I'm very flattered, but I'm not nearly smart enough to have discovered it, so please read these studies for yourselves. And it isn't a recent phenomenon invented by fraudulent scientists. Positive feedback as a forcing amplifier has been understood since at least 1969, when Charles Keating of the Scripps Institute wrote about it. This summary explains positive feedback very well, published in 1979. So to answer the question of whether temperature goes up after CO2 goes up, yes, researchers have shown that it clearly does. What Tony is wondering is why, therefore, don't temperatures keep rising when CO2 hits its peak?
We would have expected that as CO2 spiked, temperatures would have gone up too.
Well, when something doesn't make any sense to me, I don't assume that the science must be wrong. I try to find out if professional researchers have an answer. And of course they do. What researchers have found is that towards the end of each deglaciation, the forcing stops and the Earth reaches what's called equilibrium temperature. It enters an interglacial. Now, negative forcing takes effect. The most likely reason for this change is the Milankovitch cycles. As the southern hemisphere receives a little less insulation, the oceans cool, dissolving more CO2, which reduces CO2 concentration in the atmosphere. And colder conditions create more ice, increasing albedo and reflecting more sunlight. It's the reverse of what happens at the start of a deglaciation.
And look how quickly we come out of ice ages, starting with very low levels of CO2. This is the exact opposite of what we'd expect from CO2 theory.
Of course, you only need to read the published studies to see that these observations aren't the opposite, they're completely consistent. To recap briefly, the research shows that a small increase in insulation warms the oceans and that causes CO2 to come out of solution. Now, if CO2 wasn't a powerful greenhouse gas, that would be the end of the line. Research has shown that the small increase in insulation alone wouldn't be enough to melt all the ice sheets. So there would be no way to explain how each glaciation came to an end. But if CO2 is a powerful greenhouse gas, then the result would be more warming, amplified by positive feedback, bringing us quickly out of the glaciation. So how can this process be the opposite of the theory that CO2 is a powerful greenhouse gas when the entire sequence of events depends on it?
In 2004, the guy who's in charge of temperature records at NASA, Gavin Schmidt, said, "During recent decades, surface temperatures decreased significantly over most of Antarctica." Let's remember now that we're talking about Antarctic ice core records. Gavin Schmidt says the temperatures are going down as CO2 has spiked. Under Potholder's feedback theory,
Not my theory,
we
mate.
would have expected that as CO2 spiked, temperatures would have gone up too.
Okay, a lot of assumptions and misunderstandings here. The problem seems to be that Tony's only reading the abstract of the study on a NASA website. He needs to read the paper itself, where the source of his misunderstanding is revealed. In the paper itself, the authors show that ozone depletion and greenhouse gases exacerbated a phenomenon called the Southern Annular Mode, or the SAM, which defines the changing position of the southern wind belt. According to the study, 90% of the cooling at South Pole and East Antarctica stations correlated to the SAM. So their conclusion was that recent cooling over the Antarctic continental interior has likely been caused by both ozone depletion and greenhouse gas increases. Now that's a clear distinction between global warming now and global warming during deglaciations of the past. Firstly, ozone depletion over Antarctica is not something known to have occurred or been a factor at the end of each deglaciation. Secondly, while greenhouse gases are the initial forcing now, during deglaciation periods the initial forcing was increased insulation, as other studies I've cited explain. And the third difference, which wasn't in the Shindell and Schmidt paper, but which has been shown in other studies, is that during deglaciations, the initial forcing was insolation in the southern hemisphere, much closer to Antarctica. Now the initial forcing is CO2 in the northern hemisphere, much further away. So, of course, Antarctica is responding differently. Not to mention the fact that 100 years is a long period in terms of the warming we're experiencing now, but a very short time period in terms of glacial cycles.
It's been understood for a long time that if the feedback is greater than the signal, it will go out of control and there's no way to stop it. He's claiming that the feedback is much larger than the driver, or a gain of much larger than 1. If that was true, there would be no way to stop it. Once you started down into an ice age, it would just keep getting colder and colder until the whole Earth was covered with ice, and there'd be no way to get back out of it.
Well, of course, I'm not claiming this. Researchers are claiming it. And they've shown all their evidence in published papers for Tony or anyone else to read and learn the scientific explanation. I have to admit, though, I had exactly the same question years ago when I started doing videos about this. I would have agreed with Tony. It didn't make much sense to me. But instead of assuming the science must be wrong, and therefore it's deliberately faked, I assumed that maybe these professional researchers knew something I didn't. I always find that the easiest way to get an answer when you don't know something is to simply ask. So I asked some climatologists, and the answer turned out to be surprisingly easy. Once the initial forcing stops, positive feedback has diminishing returns. It's a bit like a child pushing himself on a swing. He can go higher and higher as long as he's giving a bit of a kick with his legs. But if he stops doing that and just sits there, in other words the forcing stops, then the swing will keep swinging but with a smaller and smaller amplitude each time, until it finally comes to a stop. On top of that, a basic principle of thermodynamics comes into effect, which I've explained in my videos. The positive feedback doesn't go on forever, of course, because as the temperature of the Earth rises, it radiates more heat. So once the initial forcing has stopped, the temperature keeps rising until the amount of heat leaving the Earth balances the amount of heat coming in. The Earth then stabilizes at a higher temperature called the equilibrium temperature. Another good question is, what happens if the forcing doesn't stop? What if it goes on forever? But of course every forcing eventually stops. No flood basalt event, which caused CO2 release in the past, goes on forever. Milankovitch cycles never go in one direction forever. That's why they're called cycles. So it's not a question of whether the forcing will stop, but obviously the longer the forcing goes on, the higher the final equilibrium temperature will be.
The off-cited claim that methane is a potent greenhouse gas simply isn't true.
Well, that's very easy to check. Just read the studies. Here's one that measured the spectral absorption of methane and found that although methane overlaps water vapor in the 3.3 micrometer band, it fills windows in the spectrum in the 1.6 and 2.3 micrometer bands. Their measurements show that the increase in methane concentration since 1750 has therefore led to a net radiative forcing of about 0.61 watts per square metre. Numerous other studies also contradict Tony's belief that methane is not a greenhouse gas. They show it has an estimated global warming potential of around 30 times that of carbon dioxide. I checked back in the scientific literature, and this has been known for over 4 decades.
Methane is only 2 parts per million in the atmosphere.
But as any scientist will tell you, just because something is small in quantity doesn't mean it has a correspondingly small effect. If you don't agree, try ingesting just 0.06% of your body weight in strychnine and see what effect that has. The layer of ozone in the stratosphere makes up a tiny percentage of the gases in the atmosphere, but without it, plants and animals would fry under ultraviolet light. Scientists judge the efficacy of a chemical by measuring the effect of a given quantity, not by assuming that because the quantity is small, it can't have any effect.
And it's very unstable. It oxidizes into carbon dioxide and water very quickly.
No, it takes 12 years for half of a given amount of methane to break down into CO2 and water. So if a ton of methane is released, then as a rule of thumb, half a ton will still be in the atmosphere after 12 years, a quarter of a ton will still be there after 24 years, and so on. That's why the global warming potential of methane is given according to the length of time being measured. Again, this isn't my theory, this is what studies over the last 40 years have found.
There's no way to get a large buildup of methane in an atmosphere which contains a significant amount of oxygen. It just can't happen.
And yet, here it is. Not only does it happen, but researchers can measure it. The amount is increasing as human activity and positive feedback produce more of it. The concentration has more than doubled from 750 parts per billion in pre-industrial times to around 1,800 parts per billion today. So although it's not as long-lived as carbon dioxide, it's sticking around long enough to have an increasing impact, which is why so much research is being done on its effects. Geologists are also estimating its impact on past warming.
So let's review everything Potholer did wrong.
Yes, this should be fun. And we'll put my responses in there to sum up.
First, he made the baseless claim that whatever drives ice ages is very small, even though he didn't know what the mechanism was.
A strong contender has always been regular cyclical deviation in the Earth's position or orbit, changing the amount of sunlight the Earth received. The most likely trigger was the Milankovitch cycles, changes in the Earth's tilt and orbit that caused more insolation.
Then he stated the outrageous claim that a huge amount of feedback on top of a tiny signal is what was driving ice age descent and ascent. He didn't provide any evidence for that.
A paper by Lorius et al. Shows that insolation has varied by only 0.7 watts per square meter over the last 160,000 years. Climatologists agree that the amount of forcing from the Earth's changing orbit, thought to be the initial trigger for deglaciation, had nowhere near enough energy to thaw ice covering a large portion of the planet.
And as I showed you, the climate sensitivity that would be necessary for that to occur is about 10 times higher than even the most extreme IPCC estimates of climate sensitivity.
But as we saw, Tony got that absurdly high sensitivity by looking at a graph he got off the internet without checking the data it came from, and without noticing that these are Antarctic temperatures, not global averages. And he then compared that with actual sensitivity estimates, which do use global averages.
Then I showed you using feedback theory that the feedback has to be smaller than the signal. Otherwise the climate would be unstable and Earth would either be like Venus or it would be snowball Earth.
But what you didn't understand is that this would only be true as long as the forcing continues. Once the forcing stops, positive feedback has diminishing returns. In addition, outgoing energy rises as the temperature of the Earth increases, bringing us to a higher equilibrium temperature, as I explained in my videos.
Then I showed you how his teeter-totter diagram was unsupportable because it suddenly hit the ground and stopped, but he never defined what the ground was.
The basic laws of physics tell us that the Earth will heat up in response to this extra energy, and the temperature will keep rising until the increased amount of energy radiated out matches the amount coming in, what's called equilibrium. The temperature will eventually stabilize at a higher level.
And then he made claims about methane which are unsupportable.
Well, it's supported by 40 years of solid scientific research and all the studies I've cited, which have measured methane's global warming potential, its longevity, and its increasing presence in the atmosphere.
And methane is very unstable. You can't build up large amounts of methane in the atmosphere.
And as direct measurements clearly show, yes, you can.